Hello, today we are discussing how three components form a duplex circuit. We understand for a duplex, it needs to work at two different frequencies, one for transmitter frequency, another one for receiver frequency. So basically they need two filters, two band pass filter. This is for the simplest duplex like diagram showing here. This one is a simple one. There is one band pass filter for transmitter, one band pass filter for receiver. Or some of them actually is a band stop filter for receiver here, band stop filter for transmitter here. Depends on how you like to design it. And here is the impedance match circuit. But no matter how good this impedance match circuit, there is always enough transmitter power reflect back to receiver to make the receiver not working properly. So we need to pay special attention on receive path. So we need to add another band pass filter here. For example, if our design is based on the receiver frequency here, to a band pass filter for receiver frequency, a band stop filter for receiver frequency. Let's see how the circuit formed. So we can put it this way. This is a series resonant circuit for receiver frequency. So the received signal can pass with very low insertion loss here to the receiver here. And then here is a band stop circuit for receiver frequency also. So the received RF signal will not come to here to the ground here, will stop to going to ground. But for receiver, for transmitter frequency, then this one is not a parallel resonant circuit. So the transmitter frequency power will send most of them sent to the ground. So this will increase the isolation between the transmitter and the receiver. And then here are some of the cases I designed and calculated back to 1995. The key point here is not my ugly handwriting, because at the time there is no computer or laptop available for everybody. The whole team only share one laptop, one desktop, actually desktop computer, not a laptop. So the idea is here, three components work for two different frequency. So let's see if we use this circuit for receiver path. Let's say the receiver frequency goes this way. These two inductor and the capacitor series resonant at the receiver frequency. So the signal can pass to here with very low insertion loss. And then we need to stop the transmitter frequency power. So if the transmitter frequency is lower than the receiver frequency, which means omega 1 equal to beta omega 0, beta less than 1. So we can calculate the inductor here is this value. So this is we need the inductor here. And but if the transmitter frequency is higher than the receiver frequency signal comes to this way, then we need to put a capacitor here. The again omega 1 equal to beta omega 0, beta bigger than 1. So C1, the capacitor, we can calculate this way. So omega 1 is the resonant frequency of all the three components. Similarly, we have two more cases in next slide. Here, if we need to stop, okay, this one we still use it for receiver. We need to stop the transmitter frequency power here. So this should be a parallel resonant at the transmitter frequency. But we need to let the receiver frequency signal pass with low insertion loss. So we need to calculate the L1 here. So this one, if the receiver frequency is higher than the transmitter frequency here, omega 0, then beta bigger than 1, then we can calculate L1, this value. And then if the receiver frequency is lower than the transmitter frequency, which is the parallel resonant frequency is formed by this L and C, this inductor and the capacitor here, then we need to add another C here, a capacitor here. So this capacitor C1, the value can be calculated this way. So based on this idea, I actually designed a duplex for the receiver path. Okay, some story behind is because we need to the time I was working in the RF R&D department, we need to design a duplex with very small size used for codeless phone. So we need to reduce the components number and then maintain the isolation between the transmitter and the receiver. So based on this concept, I designed a duplex for the receiver path successfully. Next slide show you the test result. So basically the receiver working at 41 megahertz and the transmitter at 26 megahertz. So we need to design the duplex for the receiver path with a low insertion loss at the 41 megahertz and a high isolation or rejection or very high loss at the transmitter frequency and then the harmonic of the transmitter frequency. So you see, this concept I don't think you can find from any textbook or seminar. This is quite a unique one. Actually, then and it's workable one. I proved, I designed, I use it, and then this is the test result. So of course, this is a very simple concept and a simple circuit. You may be apply this concept in your circuit design if you are working on the PCB layer, or even you're working on the microwave filters or duplexers. You can use this concept for different frequencies design. So this is all for today. Thank you. If you like this video, please subscribe, like and share. If you have any requirement or you like to discuss more details for other topic, drop me an email at thinkingknife@gmail.com. Thank you.